So I'm really excited today. Quarantine's weird as a chemistry teacher because all of a sudden you're like setting up curriculum and you're like, man, I've never wanted 12 molar hydrochloric acid so bad. Like you're like, why don't I have my stock room? But Mr. Murray was going to school, and so he scored me a whole bunch of chemicals so that I could do a Le Chatelier demo still. I love Le Chatelier because it's just so fun. And so I was sad I didn't get to do them this year. So I do get to do them right now for you guys. So the reaction we're going to look at is the one that's back here. This reaction doesn't look like any that you've really seen before because it's making a complex ion, which we haven't really dealt with. So just go with it. It doesn't really matter. But the reason I choose this reaction is so you can see it. If we stress the system and it shifts towards making more product, you can see that because the product has a pink complex ion that you'll see. And if we stress the system and it shifts towards the reactants, there's a blue ion that you can see. So it's a good reaction to choose because of the colors that you can see. Okay? So the sheet that goes along with it is a sheet that's online for you. And here are the stresses we're going to do. So add HCl, add water, add AgNO3, add acetone, use heat, and use an ice bath. The next column over, it says what's the resulting stress from those stresses. Essentially, where in the reaction am I like affecting? And I've listed those for you too. So HCl will make Cl minus. That should make sense. Water is going to make water. Duh. But adding AgNO3 is going to remove Cl minus. So the silver and the chloride actually will form a precipitate, effectively taking Cl minus out of solution. So that's the stress with the Cl minus. And then acetone will remove the water. And then we've got heat and ice, adding heat or removing heat. Okay, so I'm going to run through each demo for you, and your objective here is simply to predict, as we're going, based on the stress, which way the reaction will shift. And then based on the shift, what color will we see? So if you're like, oh, based on the stress, I think it will shift towards the products, then you would say it would turn pink. And if instead you think that based on the stress, it will shift towards the reactants, then you would say blue. Okay, so we're going to start out just with the pink complex. So I dissolved cobalt chloride in water, which made this cobalt water complex ion. And we're going to add 12 molar hydrochloric acid to that. So that will effectively add Cl. Now remember, the reaction wants to shift to try to undo my stress. So if I'm adding Cl minus, the reaction wants to shift to make Cl minus go away. Okay, so predict which direction it will shift based on that concept, whether it should shift more pink or shift more blue. Okay, and then let's see what happens. So if I add Cl minus to this, we see that it shifts more blue. Yes, it's purple right now because pink and blue make purple, but we effectively shifted it towards the blue side. Okay, so adding Cl minus, my reaction goes, how can I make Cl minus go away? Well, if I shift towards reactants, products will leave and reactants will show up. Okay, so we'll shift blue. Now, my next stress, I think, is adding water. And so based on what you're seeing there, if I take this and I add water to it, am I going to shift towards more pink or more blue? Make a prediction and a color. Which way am I shifting? And let's see what happens. So if I add water, it definitely shifted pink very quickly because if I add water, I want to make water go away, so I shift towards that pink. Okay, perfect. Now the next one we're going to do is we're going to shift or cause the stress of removing Cl. So the first thing we did was add Cl minus. Now we're going to add the silver nitrate to it, which will effectively remove Cl minus. So again, predict which direction am I going to shift, towards the reactants or towards the products, and then what color should we see show up. Okay. So if I add some silver nitrate to this, number one, it's going to go cloudy because I made that precipitate occur, that white silver chloride precipitate, but you see the background color turned pink. And again, that's because as I effectively remove Cl minus, the reaction wants to shift to put it back. It always wants to shift to undo the external stress. Okay. The last one we're going to do, or that I'm going to do, is do the acetone, add acetone, which effectively removes water. Again, you predict which direction it will shift and which color we will see, if I add acetone, which effectively removes water? How am I going to get the water to be put back, and what color should appear when that happens? Okay, let's check it out. Oh, geez, this acetone, I tell you. Oop, not enough. Try again. So you can see it shifted toward that blue, effectively putting the water back. I also love this one because it really shows you that concept of collision theory. That blue is only occurring at the point of contact between the solution and the acetone. Acetone's really not very dense, which is why it's kind of this floating on the surface. We could mix it and get it to be more uniform in nature, but that shows you that a reaction can't occur unless the compounds are in contact. Okay? So that's kind of the first part of that demo. I'll show you the hot bath and the water bath too. Okay, so I'm going to try the hot and the cold and see how it works for us. So I have this. So predict if I put it into hot, which direction it will shift. Remembering this is an exothermic process, so I'm going to try to shift to undo the production of heat. So if I put this into the hot and let it hang out in there. So you can see coming out of the hot water, it's definitely shifted more toward the blue side, right, by becoming purple. And if we put that in the cold instead, so remove heat, we're going to try to shift to put the heat back. So put it in the ice bath. Take it out of the ice bath, you can see it definitely turned more pink. Okay, so coming out of the ice, definitely more pink. Coming out of the heat, definitely more purple. The next thing you have to do on the second table I have in there is also predict based on the direction of shift, what's happening to the concentrations of the substances. So I'll run through one of these as an example, and then you can do the rest. Okay, so for the first one, we added Cl-. And when we added Cl- as our external stress, the shift was towards the blue, right? I shifted towards the reactants. The last question is then, what's the effect? So stress, shift, what happened? And the effect was, well, if I'm shifting this way, that means all of these things are going to go up in terms of their concentration. I'm going to make more of them. So I'll make more reactants, and the products will go down. I won't have as many because they made reactants. So essentially, whichever direction you shift towards, those substances will go up, and the substances you're shifting away from will go down. So that's kind of the repeating trend you'll see. Wherever you're pointing, things will go up, and wherever you're pointing away from, the things will go down. Do know you'll never have this happen. So you're not ever going to have a situation where, like, oh, I saw more blue, but there must have been less water. Like, that's not a thing. Things will both go up or both go down on the same side of the arrow.